Number 5, we're just finding the slope of the line tangent to this function at a f of a. So we're just doing this in general when x equals a. So we're going to use the limit as h approaches 0 of f of a plus h minus f of a all over h. So we're using that function notation again. First part, this whole part here, f of a plus h, we're just taking a plus h and putting it in here wherever we see an x. So we have limit as h approaches 0 of a plus h squared minus 4 times a plus h plus 3. So that's our f of a plus h part. Then we have to subtract f of a. Just means we're putting a in the place of x wherever we see it. Now we want to make sure that we put parentheses around this so that we're subtracting the whole function after we put a in there. So we have a squared minus 4a plus 3 all over h. So this one's going to take a little distributing, a little algebra to simplify. So we're going to go ahead and do some distributing. A plus h squared, remember that means a plus h times a plus h. So we have to use FOIL to figure that out. We end up with a squared plus 2ah plus h squared. Then we distribute that negative 4. We get minus 4a minus 4h plus 3. Distribute the minus here. Minus a squared plus 4a minus 3 all over h. So at this point, some things should start canceling out. We have an a squared minus a squared. Those add up to 0. We have a negative 4a, positive 4a, add up to 0. Positive 3, negative 3, add up to 0. Remember, at this point, all of your constants should cancel out. So you shouldn't have any just plain old constants left, which we don't. Let's look at what we do have left. We still have a 2a plus h, 2a times h plus h squared minus 4h all over h. Well, on that top, we can go ahead and factor an h out. Take an h out of each term, we end up with 2a plus h minus 4 all over h, and the h's cancel out now. So we're left with the limit as h approaches 0 of this whole expression. Well, if we put 0 in for h, all we're left with is 2a minus 4. That's going to be our slope of the tangent line. So we could use any value for a to find the slope at that point. So if we want to find the slope when x is 2, put 2 in there, we get a slope of 0. If we want to figure out the slope when x is 5, put 5 in there, we'd have a slope of 6. So we can find the slope at any point on this graph just by plugging the x value in here.